The purpose of any computer program is to manipulate data. This lesson contains a description of the arithmetic and assignment operators of Java. The form of some of the special operators were derived from C, but even if you're familiar with C, you should stay tuned because you're going to find a surprise in here. Now, this class doesn't actually do anything to produce a result. It was devised just to show you the array of arithmetic operators available in Java. All the operations in this class operate on the int values A, B, and C. Here, they're all three declared and assigned initial values. The values don't mean much in this application, but they do keep the compiler from complaining. This is probably the most common operation of all. This is the assignment operator. It causes the value to be calculated from the expression on the right and stored in the location specified on the left. This is the form that exists in almost every programming language. The operators of add, subtract, multiply, and divide can be used between any two values of any numeric type, and the result is calculated and assigned to the variable named on the left. In these examples, the data items are the same size, so there's no need to cast anything to narrow the result to make it fit. Now we come to a bit of a special situation. This is something that happens a lot. In this expression, the value of A is being modified by having the value of B added to it. In Java, this can be written in a shorter form by using the special assignment operator that adds to the value on the left instead of simply replacing it with the value of an expression. This non-traditional form of combining arithmetic and assignment into one operator was introduced in C. If you're a programmer and this is new to you, it'll take a bit of getting used to. Actually, it didn't come about because of it being some kind of convenient shorthand. It really came about because the computer on which the first C compiler was written had hardware instructions that would do this. There was no automatic optimization in those days, so it was more efficient to write code this way. Today it doesn't matter. You can write the code any way you like, and the compiler will mush it around to fit the target machine. In Java, of course, the target machine is the Java virtual machine. Now, this form of the operator doesn't exist just for addition. There are also versions of it for subtraction, multiplication, and division. And there is one other binary arithmetic operator, the modulo operator. The percent sign performs the same operation as the division does, except the result is taken to be the remainder. It isn't used as often as the other four, but it can come in very handy in special circumstances. We'll be using it later when we get into animation. And just like the other four operators, this one also can be written in the combined form. These two statements are identical as far as Java is concerned. These are the bit shift operators. The first one will shift the value of A 3 bits to the left, thus doubling the value stored in A 3 times. The second shifts the value of A 3 bits to the right, thus halving the value 3 times. Now, with this right shift operator, a negative number will remain negative by having its sign bit replicated on the left. This last one is also a right shift operator, but the sign bit will not be extended, causing a negative value to become positive. The shift operators can also be written in the combined form. In fact, with the shift operators, this is probably the more common form. The last of the binary operators are the bitwise operators. Now, these only work on integer values. The ampersand is the bitwise AND of two integer values. The vertical bar is the bitwise OR of two integer values. And the caret is the exclusive OR of two integer values. Now, these bitwise operators are not really used that often, but special circumstances arise where you do need them. There are a couple of special operators in Java that are used to add one or subtract one from a variable. These are called the increment and decrement operators. Now, this block of code sets the value of A to 5, prints it, then prints it again as it is being incremented, then prints it a third time to show the final result. Now, this is called a post-increment because the increment does not occur until after its value has been used in the statement. That is, Placing the plus plus after the A means that after everything else in this statement has been completed and calculated, 1 is added to A. Now this is the pre-increment form of A. This works the same as the post-increment form, except 1 is added to A before anything else is done in the expression. Now the decrement operators are written as a minus minus and can be used as either a post-decrement or as a pre-decrement, except it subtracts 1 instead of adding 1. In this example, the value of A is set to 5. Then the values are printed that demonstrate how the increment and decrement operators work. Here you can see the result of a post-increment, which doesn't show up until after the statement on which it occurred has finished, where the pre-increment shows up before it's been used in the expression. The same is true of the pre- and post-decrements. If these operations are new to you, I suggest you examine the example program and compare it to the results. These operators are used a lot in Java, as well as in C and C++ for that matter. Well, that's about it for operators. In an upcoming lesson, we'll be looking at the Boolean operators, which are used to compare values of two numbers, but it's easier to explain those in terms of if and while. But this lesson contains everything you need to do arithmetic in Java.